Increasingly, the media is beginning to take scientists seriously, believe it or not, and point to the seriousness of the changes that we face. All indications are that we need to make some big changes ourselves individually and as communities in the near future. And I wanted to let you know I'm just thrilled to introduce Dr. Richard Gammon today to share his knowledge and perspectives on the situation we find ourselves in. I met Dr. Gammon last year at an Audubon presentation, and I found his talk very timely and informative. I think you'll find it so today, too. He's inspired me and several other people in this room to get out and talk about this topic and start to build some better understanding in our community and world. So Dr. Gammon is a Professor Emeritus of Chemistry and Oceanography and an Adjunct Professor Emeritus in Atmospheric Sciences at the University of Washington. He received his Ph.D. in Physical Chemistry from Harvard in 1970. He's a co-author of the first scientific assessment by the Intergovernmental Panel on Climate Change, the IPCC, you've heard in the news. As chief of the carbon dioxide program, he directed the U.S. government's program to globally monitor atmospheric CO2. Dr. Gammon has taught undergraduate and graduate courses in chemistry, oceanography, atmospheric science, bio-geochemical cycles, and climate change. His research has emphasized the measurement and interpretation of atmospheric trace gases critical to climate change. He lives on Whidbey Island and maintains an active program of presentations to inform the public about climate change science. Please join me in welcoming Dr. Gammon.
Well, thank you very much, David, and I'm very pleased to have a chance to talk to you today. As I understand it, I can talk for kind of like a lecture, 40, 50 minutes, and I will talk rapidly. I hope that you'll hear me. Raise your hand if you don't hear me. And then we'll have time for questions, and I invite your questions. And I know that this is being videotaped. You can see the whole presentation again later at a slower pace, because I do go pretty fast. And also you can send me email, gammon@u.washington.edu, for any sort of follow-up questions that you might have. Okay, in the upper left is the polar vortex. Yay, see that? The difference between the blue, cold air, and warmer, so that sort of loopy polar vortex is probably due to climate change, and this big blob of cold air in the middle of our country for a long time. Weather systems were not just sort of moving through every 3 or 4 days, but lingering for days and even weeks. So this is one aspect of climate change, changing seasonality, changing our weather patterns. On the lower left, that's my grandson. He's tiny. Actually, he's off the charts. He's more than 1%, lower than 1% on height and weight. He's so cute, though. And there, he's on the beach there in Santa Monica. And the reason I show that is that where he's standing will be underwater in his lifetime. We may lose a third to half the beaches in California with sea level rise. We'll come back to sea level rise, and as you learned, you'll have another talk about local sea level rise at your next meeting. So let's go. As was stated, I helped to write the carbon cycle chapter for this 1990, the first report from the IPCC. Note the language. This is in the executive summary. It's not possible at this time to attribute all or even a large part of the observed global warming, blah, 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 blah. Weasel words, very cautious scientific language, right? Yet, 5 years later, look at the language. The balance of evidence suggests, what is that? That's the standard in a civil court of law, balance of evidence. What happens in the next report, 6 years later? Likely. Most of the warming is likely, and likely means 2 out of 3, 66%. These are quantified. And then in the next report, 2007, most of the warming is very likely. Now we're at 90%, 10 to 1 odds. Very likely. And then going from there, the next report, the last one that's been issued, there'll be another one in another year or so, it is extremely likely. Now we're at 20 to 1 odds that it's not natural. We're now at the criminal standard. Murder 1, conviction, going to jail for life. or capital punishment. So think about the civil standard, balance of evidence, versus the criminal standard. We're beyond the criminal standard in the evidence that climate change is happening and that we are responsible for it. So let's not talk about so-called law or so-called theory of global warming. It's like, sort of like so-called theory of gravity, right? You believe in gravity? Yeah, okay. So this is where the science is. And these are scientifically conservative statements by the brightest and best scientists around the world who've been doing this for 30 years. So the latest report says, and there's the arrow that shows you, these are the percentages and the odds. We're up to extremely likely, better than 95%, as close as we can come to certainty. And nothing in science is ever absolutely certain. It's always provisional truth in science. Can be, if it's not potentially refutable, then it's not science. Science is always provisional truth. It is extremely likely, 95 to 100%, that human influence has been the dominant cause of the observed warming since the mid-20th century. QED, done, okay? That's where we are. That's where the scientific community is, the international scientific community. But, so the basic science of human-caused climate change is no longer in question. Did the people know that? No, there's where the scientists are, but the people, the US public says, well, the scientists are still debating it, right? No, they're not. They're not. It's not 50-50. It's not 70-30. It's 95% or 97% agreement that climate change is happening now and it's caused by human emissions of greenhouse gases. As Gina McCarthy said, the scientific certainty about climate change, human-caused climate change, is greater today than the long-accepted fact that smoking causes cancer, okay? We're beyond that in terms of our understanding. That's where we are. You can have your own opinion, but you can't have your own facts. So here's the actual temperature record. Notice that we set records the last few years. 2015, 16, 17, 18. All of these are above the long-term average. The long-term average, we're now about more than 1 degree centigrade, 2 degrees Fahrenheit above the pre-industrial temperature average. And this is actually the temperature anomaly pattern for the last year, for 2018. But if I said that for last 5 years, last 10 years, last century, it would be the same pattern. The pattern says the warming is greater in the northern hemisphere than the southern hemisphere. The warming is greater on the land than over the ocean. The warming is greater at high latitude than low latitude. All in this picture, and all true in every year or every summary of years that you could put together. And not shown here, the warming is greater in the winter than the summer. The warming is greater at night than during the day. Only greenhouse gases do that. Not solar variability, not volcanoes, nothing else. Only greenhouse gases explain that pattern. Over here is the record that Dave Keeling started in 1958 at Mauna Loa, Hawaii, of the increase, the global increase in atmospheric carbon dioxide. This is actually pretty representative for the northern hemisphere, and it's used as a proxy for the world. I was actually in charge of this network for the US government in 1982 to 83. I got to go to the mountain with Dave Keeling and convince him, Dave, you're going to die. This measurement needs to be institutionalized. The government needs to be doing this. Yes, the Scripps Institute can continue the record, and his son, Ralph Keeling, continues the record for Scripps side by side with the NOAA measurements, minute by minute, carbon dioxide. This also is being done minute by minute at Barrow, Alaska, American Samoa, and the South Pole. So we have our finger on the pulse of the planet, and we know what's happening. Since I was in charge of it, back when the atmosphere was 340 parts per million, and growing about 1 a year. Now we're over 400. More than half the CO2 that's in the air has been put in the air since 1983. More than half of it has been done since then. The bottom picture just shows you the seasonal cycle of the last couple years. Spring, summer, fall, winter. Spring, summer, fall, winter. Spring, summer, fall, winter. That's the breathing, photosynthesis, uptake, and release by all the land plants in the world. That's what the seesaw is on this record. Notice this curve is bending up. We want to stop it from increasing. We want to bring it to zero, net zero, carbon equilibrium in our lifetime, maybe not, at least in the lifetime of our children, by 2030, 2040, for sure by 2050. That's the challenge ahead of us. How do we stop that? How do we stop that when India says, you burn coal to get rich, don't tell us not to burn coal. We have a right. And then they do in that sense. So the latest report, every 4 years, there's mandated from the Congress a report by the U.S. scientists about the impacts of climate change on the United States. And this was the National Climate Assessment, and it was issued last fall, the Climate Science Special Report, Chapter 1 of that, about the climate science and the United States. So you can Google this and read the report. I'm not going to go in detail over some of the findings. Again, there's the temperature record since pre-industrial times. This is, again, the pattern of warming. That one is an average over the last century or so, but it's the same pattern as I showed you for 2018. Now, what's causing the warming? We are. What about solar? No. What about volcanoes? No. Only human activity. Okay? Done. This is what the science says. And so if you want to look over a longer time scale, the warming over the last, since 1800 or 1850, we're now warmer than at any time since we came out of the last ice age. Since we figured out how to do agriculture, establish cities, written history, culture, all of that. We're beyond that. We're back in a different climate already. And if you say, if you want to look at where we're going is sort of off scale in terms of our experience as a species. So here is, at the bottom graph, is the direct measurement of carbon dioxide in ice cores from the South Pole, from Antarctica. No assumptions, just crack open the ice, capture the CO2 that's trapped in the ice, and measure it. And you can see that the warm periods are typically about 250, 280 parts per million, and the cold periods about 180 parts per million. And there's nothing that's 400, and we're over 400, we're at 420 now. There's nothing in the last million years. If you want to say, how far back do you have to go to get a carbon dioxide in the atmosphere like we have today? 3 million years? 3.5 million years? There were no people. There was no genus Homo, no Neanderthals, nothing like that. And maybe back to 6 or 7 million years or beyond when we split off from the chimps. That's what we've already done to the atmosphere in terms of CO2. Not the climate yet, not the temperature, not the sea level rise. That's coming. There's a lag in the system. But in terms of what atmospheric CO2 is, we've already done it. And we're racing ahead toward some other climate that we know very little about. The top shows the historical sort of bell-shaped curve for cold times, normal times, and warm times in northern hemisphere temperature from 1950 to 1980. And the bottom curve shows the actual temperature distribution for the last decade or so. Notice the shift. We're over here now. A lot of hot times and fewer cold times. So the actual average seasonal temperature for the northern hemisphere is something different. And if you're growing corn in the Midwest, you know this. You know that the seasons are changing. You know when you can plant. The growing seasons are changing. Frost-free conditions are changing. Some of it good at high northern latitude, longer growing seasons. Not so good if you don't have the water. This is just looking out to the middle of this century and then the end of this century for a high emission scenario. So this is some of the temperature patterns predicted. Again, the greatest warming will be at high latitude. Where we are, in this particular scenario, we're going to get 3 or 4 degrees centigrade, 6 to 8 degrees Fahrenheit, warmer than we are now. And this is showing the changes in rainfall predicted per degree centigrade. So if we get 3 degrees of warming, then you can take all of these numbers and scale them up. The point of the figure is to show that in the Mediterranean region, in our southwest, and throughout the Caribbean, and even parts of the Amazon, in South Africa, in Australia, the subtropical regions of the world are going to dry out. Where they're dry, they're going to get drier. And high latitudes, it's going to have more precipitation. And whether it's rain or snow depends upon where you are. And we're kind of on the border between more precipitation and less precipitation. So maybe, on average, we won't have such a big change. We'll have a lot more rain and a lot less snow. That's for sure. The glaciers are receding. We know that already. And more rain in the tropical rain belt as well. So this is just to show you the pattern of changing precipitation, which we think is coming, has already begun, actually. And this explains a lot why people will be moving when there's no water and you can't grow things. So this is just looking at the North American continent. These are some figures from NASA about now, 2020, the pattern of drought in the western U.S., and looking out to the end of this century. Look at that. Whoa. This dry corridor, it's called, goes from Mexico, southwest down Mexico, all through Central America. Now, those people won't be able to grow anything. They're going to move. Where will they move? They'll be coming here. Looking at the sea ice in the Arctic, it's going down, 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 down. And so an ice-free Arctic Ocean, a blue water ocean in the Arctic in the summer, may happen in the lifetime of our children. The Russians, the Canadians will enjoy this. There'll be ships going across the top of the world. Shipping from Europe to Asia across the top of the world is already beginning now, and that'll be more in the future. Now, if you're a polar bear or you're a native Inuit of the North, then these conditions are not good for you. At the other pole, we have glaciers like the Pine Island Glacier, Pig, and the Thwaites Glacier. These two are the plug for a lot of ice behind them. If they go, then a lot of this ice will be released, and many, many feet of sea level rise just from these two glaciers alone. And as Eric Renaud has said, the Western Arctic glacier loss appears now unstoppable. We may have already passed the threshold for this. We may not be able to stop this. It's only a question of whether this happens in the lifetime of your children, your grandchildren, or your great-grandchildren. How far in the future do you think your responsibility extends? 7 generations? That's pretty far out. So sea level rise was pretty, for the last 1,000 years or so, was kind of up and down, not much. And now sea level is going up about an inch every 10 years. In the bottom is sea level rise. Maybe we're just going to get 2 or 3 feet by 2100. Maybe we'll get 8 feet. Who can tell me what are the odds of getting multi-meter sea level rise, 6 or 8 feet? Well, it's not the most likely, but it might happen. Are any of these curves bending over? What happens after 2100? What happens in the lifetime of your great-grandchildren? The children born today who will live beyond the end of the century. Don't we have a responsibility to them if we can turn this around, if we can stop this now? So here in the Pacific Northwest, this is a figure from the Department of Ecology. We know we're having warmer temperatures, reduced snowpack, and glaciers are receding, extreme weather events, and rising sea level. Sometimes extreme storms come in with high sea level and high tides and are already impacting your beachfront house or beachfront cottage, especially if it's south-facing. So there's a group called the Climate Impacts Group at the University of Washington. They issue regular reports on the impact of climate change on the state of Washington. My former graduate student, Amy Snover, is director of this. And so I want to be careful what I say. This is climate change impacts and adaptation, and this is a look just at Puget Sound. So every couple of years these reports come out, and they become, in fact, the statement about climate change from the state of Washington. They take on official status. Now, the reports are good. I think that they're kind of a little bit too anodyne. I think they're a little bit too reassuring. I actually think we should be more alarmed than these reports would have you worry about. We'll come back to that idea. So this is just a glaciers, snowpack, wildfires, rising sea levels. And here's a time-lapse, a picture from a glacier on Mount Rainier before and now, just to convince you that glaciers in our Cascades are receding. And we rely upon the glaciers for water in our rivers in the summer, of course, and our hydropower depends upon the glacier melt as well. This is a picture from, I think, last year showing that, yes, there's adequate snowpack some places in the Northwest, but in California and Oregon and further to the southeast, we have been in a snow drought, and this will get worse in the future. The water in the Colorado River is entirely spoken for. We're renegotiating with Mexico and southwestern states about how to divide up a shrinking resource. Last summer and the summer before, the first time I remember that we didn't have blue sky, we had that smoke, and it wasn't just Oregon and Washington forest fires. There were forest fires in BC, and they were in Siberia as well. In Russia, smoke comes across. So is this our future, that we lose our blue sky in the summer? I wouldn't like to think that. And unhealthy air, for a while we had some of the worst air in the world in the Pacific Northwest. In the lower right is a figure showing where the fires have been over the last few years in western United States, and the graph at the very bottom shows the increase in area burned, I believe. Here's the Keeling curve again for atmospheric CO2, and this is CO2 in the water, and this is the pH, or alkalinity, acidity of the water. So the pH getting down means the waters are becoming more acidic. So this is ocean acidification. And this is a global phenomenon. It's especially important at high latitude, where we are. High latitude ocean is more liable to have ocean acidification. When we lose the coral reefs in the tropics, it's not ocean acidification, it's temperature. Too hot for the corals. Up here, ocean acidification is important. And the rate at which oceans are acidifying is the fastest that it's been since the death of the dinosaurs. The rate at which CO2 is going up in the air is probably the fastest it's ever been in geological history since the beginning of multicellular life with the Cambrian explosion 500 million years ago. CO2 is going up, oceans are absorbing a part of that. That's why oceans are acidifying at a fantastic rate. And so what does it mean? I love oysters, and fish, including salmon, love these creatures that are like pteropods that make a calcium carbonate shell. If the waters are too acidic, they can't make their shell. And oysters or larvae dissolve before they can grow. So this is an issue for our wildlife, for our salmon, and for our shellfish here in the Northwest. Now, one thing that would help is protecting eelgrass and kelp, because they're plants and they take CO2 out of the water, and they make the water less acidic, which is good, and they provide habitat as well. Now, this is kind of a weird thing. Did you remember that? The main stem of Puget Sound is over here. It's dark, you can't see it, but the Hood Canal turned bright green that summer. A very unusual phytoplankton bloom. Completely unexpected. Not toxic, but weird. Never seen before. The blob. We have warm water off our coast, and this has affected our crab fishery for some years. It affects the salmon. Yes, it's related to El Nino and maybe something else, we don't really know. Our state climatologist called it the blob. So the blob was here for like 2013 for 3 or 4 years, and it affected fisheries all up and down the coast. And now warm water seems to be back with us. So changing ocean conditions looks to be in our future as well. An elder of the lower Elwha Clallam tribe said, "It's a long canoe and we're all in it." It's a great statement. It's a long canoe and we're all in it. Now this grieving mother orca with her dead rotting baby on her head swam slowly for 17 days and 1,000 miles. And whenever that carcass fell off her head, she dove down and got it and put it back on her head and kept swimming. If that's not grief, I don't know what is. The waters are getting too warm. We lost half the sockeye in the Columbia River a few years ago because it was too warm. And it was too dry to plant winter wheat in eastern Washington that year. I think it was 2015. There used to be a lot of these starfish, and then we had starfish wasting disease. Now it's really hard to find starfish on our coast. And the sunflower starfish, this creature, is basically extinct from San Diego to Alaska, the giant starfish. And we have some invasive creatures. This is not Dungeness crab. This is some European green crab competing with Dungeness. Now, this was just a slightly broader view. There was a look at the economic impact of climate change on the United States. And the brown colors mean bad, and the green colors mean good in terms of changes in GDP at a county level. And look at where climate impacts will be bad, and look at where climate impacts will be not so bad or even beneficial in terms of growing season, for example. Where are these people going to go? They're going to be coming here. What wall are we going to build to keep them out? One summary statement about oceans is oceans are getting hot, sour, and breathless. What does that mean? Oceans are warming. The ocean heat content, about 94% of the heat, excess heat from greenhouse warming is going into the ocean, and about 1/3 of the carbon dioxide. If we want to stabilize the climate, that heat's going to come back out, and that CO2 is going to come back out. What's the circulation time of the ocean? 1,000 years. 1,000 years. So this isn't something that's going to be solved in the lifetime of your children or your grandchildren or your grandchildren's grandchildren. It's way in there. It's going to be in the rock record. Whatever intelligent creatures are on this planet 10 million years from now, when they do fossil archaeology and look in the rock record, they will see the Anthropocene, the epoch that we're causing now. We are the major geophysical force on the planet. So hot, oceans are getting hot, they're sour, that's the acidification, and breathless, because warmer water holds less oxygen. Hot, sour, and breathless, that's the future of our oceans. I was just in French Polynesia and Tahiti, and I was able to snorkel on some of these reefs, and I was looking for damage on the reef. I didn't see a lot of bleaching. I did see a lot of soft algae. But to me, as someone who loves to see the coral fish and the reef, I can't imagine a world with no corals. If we can stop the warming at 1.5 degrees C, and I don't think we have a shot at that, actually. I think that's in the rearview mirror already. Then we'd only lose 85% of all the coral reefs in the world. If we let the warming go to 2 degrees, and we're aiming for 4 right now, if the warming could be stopped at 2 degrees, we lose 99% of all the tropical coral reefs in the world. So you could tell your grandchildren and your great-grandchildren, if you live that long, yes, we used to snorkel in Hawaii, we saw the fish on the reef. I'm sorry, you'll never see that. You will never see that. Okay, sea level. All of these curves, what bothers me is that most of these curves for sea level, they stop at 2100. Are any of these curves bending over at 2100? No. They're accelerating up, right? And does our responsibility stop at 2100 if we could do something about it right now? Is it only going to be 1 feet or 4 feet? Or that's 2 meters right there, 6.6 feet. With what odds? How do we know that? Even a sea level rise of 3 feet will destroy thousands of islands in the tropical Pacific. Whole nations will disappear underwater. You talk to people from Tuvalu or the Marshalls, and they say, you're destroying our culture. Graves of our ancestors, all of our sacred places will be gone. How can you do that? Eyes wide open. How can you do that? So, sea level rise danger in the U.S., our risk is about like California or Texas. Oregon is less, they have less low-lying land than we do, but we're nothing like Louisiana or Florida or South Carolina. So let's look in a little more detail at some of the impacts of sea level rise in the Northwest. So here was a recent report, again, from the Climate Impacts Group at the University of Washington. Ian Miller was the main author. He gave a recent presentation at the Sound Waters University Saturday, February 2nd, and I went to his talk, and I spoke with him afterwards. And I said, Ian, how can you say that the chance of a 6-foot sea level rise in the Puget Sound is less than 1 in 1,000? How can you say that? Since the Oregon won't say that, the National Climate Assessment won't say that. They said it could be 8 feet, and we cannot at this time assign a probability to that. So let's just say it's out there as a possibility. What's 1 in 1,000? That's not so bad. What's 1 in 1,000? Well, that's the chance that you will die in a car accident in the next 10 years. And you think about that. So think about 1 in 1,000 that way. It's not small. And I don't actually think that's accurate. I think the odds are going to be much greater than that we'll have multi-meter sea level rise in this century, or certainly in the lifetime of your children, your grandchildren. So this is another area where I disagree a little bit with the Climate Impacts Group. I think that that's a little bit too reassuring. I think the future is uncertain and could be worse than that. This report from the Union of Concerned Scientists together with Zillow, the real estate people, you can use this interactive map and go anywhere in the U.S. and scale down and look at any community, including Bellingham. And you'll get more of this in your next talk about local sea level rise. But there are other products out there that will let you estimate, and I'm trying to do that for Island County, estimate what fraction of the beachfront cabins and houses at the high tide line will be lost. Tell people, don't buy that house for your grandchildren. It's a bad investment. It's not going to be there. So here's one that seems to grab people. What if you can tell your grandchildren, oh, we used to go to the Skagit and see the tulips? I'm sorry, you'll never see that again. It's underwater now. When is that coming? Well, it could come by 2050, almost certainly by 2100. Can we build dikes enough to stop the river and stop the ocean? I don't think we will. I think we'll lose the Skagit. All of that area will be lost, all of that. And these towns are especially at risk, the ones in red. Conway, Edison, LaConner, what else is there? Oh, Whidbey Island Naval Station, etc. So, anything that's at the high tide line or within 4 or 6 feet of the high tide line is at risk in the lifetime of your children and your grandchildren. So John Holdren, who was the science advisor under Obama, said these are our choices now: mitigation, adaptation, and suffering. Mitigation means avoiding the change to which we cannot adapt. And I think that if we had warming of more than 5 degrees centigrade, that's something we cannot adapt to. That's basically an uninhabitable world for many people. Uninhabitable, not uncomfortable, not inhospitable, uninhabitable. Hundreds of millions of people dying and being refugees. So, uninhabitable. Adaptation, preparing for the change we can no longer avoid. We're going to get 2 degrees of warming, maybe more. Let's get ready for it. Let's adapt to that. Let's plan for that now, because that's coming. We cannot avoid it. And suffering. Minimize human suffering and damage to the natural world. We've lost half the animals in the world since 2070. Half of nature is gone. My grandson picks up a rock and he sees a clam on the beach here, and he says, "Granddad, is that nature? Granddad, is that nature?" "Yes, Harrison. That's nature." So corn yields. Reports, including Dave Battiste at University of Washington, we're going to lose 10% of the corn crop for each 1 degree centigrade warming. So if we have 2 degrees or 4 degrees of warming, look at our corn growing areas, okay? Look at our corn growing areas. Look at corn growing in Mexico and other places in the world. We have a population that's going to grow from 7 or 8 billion to 10 or 11 billion, and yet the corn yields are going to go down by 20 or 30%. How does that compute? Well, we're going to need new hybrid corn, better drought and pest resistance, better water storage. Let's get on it. So in the top, in red, are all the countries that are producing the CO2. Notice us and Europe and Australia. And blue countries up there are not producing any CO2. But who's going to suffer? Now look at the bottom graph. Those that suffer the most have been least responsible for the emissions. We're benefiting from burning fossil fuels, and we're not going to suffer. And people that aren't burning fossil fuels are going to suffer more, a lot more. Same, hunger, climate, vulnerability index. Again, the greatest risk for the people least responsible. There's a strong moral argument here. It's not just here in Washington State. We owe people around the world. When we put CO2 up and don't pay anything for it, it's not free. We're just not paying the price. We need a price on carbon. Deadly heat waves. It'll be too hot. You know that if it's more than 95 degrees and more than 95% humidity, you can die in 2 hours just sitting in the shade. You can die asleep at night. So when large parts of the world will be uninhabitable, nobody can work outside in the day. Where will those people go? People will move. If they can't eat and they're dying and they can't grow anything and there's no water, they will leave. Climate refugees have no international status, none. There's refugees from war and domestic violence, etc. There is no legal status for climate refugees. That has to change. Yes, that's true that China is now emitting more carbon than we are. They passed us, a decade ago. But carbon emissions per person, we're still #1. And if you say what matters, what stays in the air, is the total amount of carbon put up since the beginning of the Industrial Revolution. So cumulative carbon emissions per person, we're way up there. China's not even on the charts, okay? What about China? Are they doing anything? Yes. China's investing much more in renewables than we are. They're building many more electric cars than we are. They're doing much, much more than we are in terms of beginning to adapt to a changing world. So let's not say we're not going to do anything until China does something. China's doing something. What do we have to do? We've got to stop the increase and start down. Whether we have a chance at 1.5, I don't believe it. It'd be wonderful if we could stop at 2 degrees. And notice that some of these curves go negative. What does it mean to go negative? That means we have a way to take the carbon dioxide back out of the atmosphere. You can do it with special machines at $100 a ton or $200 a ton, which we're not willing to pay for yet. You can do it with changing soil practices and reforestation and afforestation. That'll help. That's not the whole thing. We're going to have to be sucking the CO2 back up that we're putting out there. Much better not to burn it. In order to have any sort of trajectories like this, to stopping at 2 or 3 degrees, we're going to have active carbon dioxide removal. We'll talk about this maybe in the question period. Okay, so if we're there now, 40 gigaton CO2 equivalent, and we want to get down by 2040 or 2050, I'm not so sure about the Green Deal. We're not going to make it by 2030. But let's imagine we want to get down by 2050 to a carbon neutral world. Is that safe world? No, that's not safe. That's just the beginning of the process to get the carbon back out. But anyway, cut it in half in 10 years, and then cut that in half in 10 years, and then cut that in half in 10 years. Can we do that? Cut it in half in 10 years, and then cut that in half in 10 years, and then cut that in half in 10 years. That's what we have to do. 8% per year reductions. We're doing 1% a year or none. Actually, we went up last year. Emissions in the U.S. went up. And even that is not quite enough. We have to stop all tropical deforestation, and then we have to suck out with machines another gigaton or so. Then we'd be carbon neutral by 2050 as a world. So cities and counties and states and nations are now pledging to reach carbon neutrality by 2035, 2040, 2045. That's what we need to do, those aspirational targets and ways to reach them. Some good news. Hey, the ozone hole is healing. Yay! The Montreal Protocol is working. International treaty with teeth and provisions for developing countries to use the freons a little bit longer before they had to shut down. So there are lessons in the Montreal Protocol for us in terms of the Kyoto Protocol and the Paris Accord. We need international treaties, binding international treaties that get us on a track to reduce our emissions. So here's a guy like me up front, giving a talk, green jobs, livables, renewable, blah, 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 blah. And the guy in the back saying, hey, what if it's all a big hoax and we make a better world for nothing? Well, that'd be fine. A better world would be fine. So almost done, a few cartoons. This was in New York Times. I love this. Big headline. Stopping global climate change is hopeless. Let's do it. It's hopeless. Let's do it. If the odds are bad, wake up in the morning and change the odds. Get out there. I like David Suzuki's quote. I'm urging elders all around the world to get the hell off the golf course. Get off the couch. This is the most important time in your life. Damn it all, get out there and speak and tell the truth. Yeah. It's too soon to act on climate. It's only a theory. It's still too soon. No hard evidence of any warming. It's still too soon. Yeah, there's warming, but the cause is not clear. Now's not the time. We need to ponder the costs and the benefits. Still too soon. There's no 100% consensus to act. Okay, finally, it's not too soon. Now it's too late. Have you heard that story? Greta, that little 16-year-old girl, she went to Davos. I don't want your hope. I don't want you to be hopeful. I want you to panic. I want you to feel the fear I feel every day, to act as you would in a crisis. I want you to act as if your house is on fire, because it is. If you want the real doomsday, and I'm not giving you worst case, you can read the New York article by David Wallace Wells or his new book, The Uninhabitable Earth, if you want worst case. Well, Kathleen Dean Moore said, okay, knowing all this, how then shall we live? How then shall we live? Or as Naomi Klein says in her book, this changes everything. Yogi said, it's getting late a lot earlier now. And Wallace Stevens said, after the final no, there comes a yes. And on this yes, the future world depends. Wendell Berry said, whether we and our politicians know it or not, nature is party to all of our deals and decisions, and she has more votes, she has a longer memory, and a sterner sense of justice than we do. So I'm going to leave this up and have it for questions, because I was called Dr. Doom. If you give the straight science and stop, people said, oh, that's horrible. Tell me what I can do. Okay, this is what you can do, so we can talk about this. What can you do personally in your own life, and what can we do politically as a group, as a city, as a county, as a state? And so we can come back to these figures. I just want to emphasize two things. One, I belong to Citizens Climate Lobby. There's a bill before the Congress for a carbon fee and dividend. That's one thing you can do. And if you're worried about people in the developing world, another group that I belong to is called El Porvenir. It means the future. And this delivers clean water, sanitation, and reforestation for rural areas in Nicaragua. So in terms of your own giving for NGOs in the developing world, that's important because they're already suffering from climate change that we caused. And there are things you can do in your own life in terms of your diet, how you drive in your car, energy use in your home, all of those things. Not just changing the light bulbs. Sure, do that, and then do the next thing beyond that. Local issues you know about. I don't have to talk about that at all. And I'll stop there. Thank you very much.
Well, thank you, Dr. Gammon. Appreciate the presentation and the thoughtful remarks. We have a couple questions for you.
You told me you were going to do this.
Yes, we told him. You mentioned removing carbon dioxide from the atmosphere mechanically,
yes.
And right now it's pretty expensive. What's your thoughts on whether that will ever become really feasible or not?
Okay, it's called, one sense it's called negative emissions, right? Emissions are what we put up. Negative emissions would be creating sinks to take carbon dioxide back out of the air. And so one would be natural. And maybe 20 or 30 years ago, we could have said, we're just going to do reforestation and soil conservation, and that'll take care of it. No, it won't now. It might do 10 or 20%. No-till, agriculture, cover crops, crop rotation, all of those things. Better agriculture, we can do that. And that might take a gigaton out. If you say, I want to soak up all the emissions of the United States by planting trees, that's the entire area of the United States in tree plantations. Reforestation, afforestation, changing soil practices is an important part, a small part. If we really want to take the CO2 back out quickly, we need machines that scrub the CO2 out of the air. It's only 0.04%, right? 400 parts per million. And then compress that CO2 and put it safely, geologically underground where it never comes out for thousands of years. Can we do that? Yes. David Keith with Carbon Engineering in British Columbia has demonstrated this. Climate Works in Switzerland has demonstrated this. Right now, there's no market for it, and nobody's going to pay for it, right? There's no price on carbon. If we pay $50 or $100 a ton for companies to do this, for our benefit, and put it safely underground in basalt formations where it reacts with the rock and makes a solid phase, we could do that. Now, these people who are doing it, they think they can do this for $100 a ton. Right now, countries and states are rejecting carbon fees of $15 or $20 a ton. I think north of us, British Columbia, has a carbon fee. What's the number? $30, $35 a ton? Something like that. Yeah, we can do that, but it's going to have to get a lot higher before. Now, $1 a ton is a penny on a gallon of gas, okay? So $15 a ton is 15 cents higher on your gallon of gas, okay? We could do that. When it gets to be $100 a ton, then you're talking real money, right, in terms of the price of gasoline. Are people willing to do that? Maybe we'll all have electric cars by then. We'll see. Anyway, yes, in theory, we can scrub CO2 out of the air onto an alkali surface, regenerate that surface, compress the CO2, and put it safely underground in geological formations. Is anybody doing that on a large scale? Only oil recovery people. They use CO2, squirt it into the old wells to push out more oil. That's the only use. Oh, a little bit for soda. You take the CO2 and sell it to companies so they make carbonated beverages. That's not the market we're talking about. But yes, in theory, it's possible. We can do it. And we need to move quickly in that area because we've waited too long. We're going to have to be, once we stop increasing CO2, then we're sitting at 500 or 600 parts per million, which is not safe. It's not safe. We got to get back, that's what 350.org means. Get the CO2 back down to something like the CO2 level of the world in which we evolved, which was 280 or 300.
So, Dr. Gammon, is there any low-hanging legislative fruit that local, state, or federal authorities can adopt to address climate change?
Well, you know that we tried with ballot initiatives 732, which failed, and 1631, with a lot of oil money against it. It failed, but it did a little bit better, a little bit better. And I think this latest initiative, 1631, it passed in King County, San Juan County, Jefferson County. I think that's all. Direct attempts in this state to pass a price on carbon have not been successful. Now, there are bills before the legislature now in Olympia, and I'm not up on all of that, and our governor is very, very progressive in terms of his views on climate change. At the national level, there's this carbon fee and dividend bill that's supported by the Citizens Climate Lobby, and I urge you to join that group. And there's a new Green Deal, whatever that means. We'll see. We need something like a new Green Deal. We're going to have to meet climate change, and it's not just a stalking horse for other leftist social agenda, but we do need to deal with our emissions as a nation. Certainly, we should not leave the Paris Accord. We need to be in that. We need to strengthen the Paris Accord. Somebody said, oh, Paris, that's just non-binding statements by countries of what they might try to do. It's like you're in junior high school class and the English teacher assigns a paper, but you never have to turn in the paper and you never get a bad grade. All you have to do is go to assembly every 2 weeks and show the other kids your homework. That's what the Paris Accord, there's no teeth in it. There's no penalty for noncompliance. It's just aspirational. We're going to try to reach carbon neutral by 2040 or so, and we didn't make it, but then we'll try by 2050. So we need Paris and a lot more than Paris if we're going to keep the warming under 4 degrees, 3 degrees. I don't think we have a shot at 1.5. I would love to see the world stop at 2.
So given that aspiration, do you think we have a shot at it?
People ask me if I'm hopeful, and there are two kinds of hope. There is the hope like, gee, I hope the scientists come up with something, or I hope it won't be that bad. That is an extrinsic hope, hoping for a particular outcome. There's a deeper hope, which is closer to religious faith, which is an intrinsic hope, which means I'm going to do the right thing, no matter how it turns out. I'm going to act correctly. And whether that's changing the light bulbs or supporting Citizens Climate Lobby or whatever. So in that sense, I'm hopeful. I'm not optimistic, but I'm hopeful that we'll do the right thing. I think our children and our grandchildren are going to have a worse future than we have had, than the life we've had. I think 50, 100 years, 150 years out, we may hit the worst, and then things will start to get better. But the first rule of excavation is when you're in the hole, stop digging. So let's stop digging up fossil fuel. Let's not fund any new fossil fuel infrastructure, whether it's a pipeline, refinery, whatever. I know our neighbors to the north want that pipeline. Not everybody around here is in favor of that. Maybe if you work for a refinery, you are. All of those people in the refineries, they're going to be retrained for other jobs. There are a whole lot more people putting up solar and wind than there are digging coal, for sure, already. Renewables are cheaper than building or even operating an existing coal-fired power plant. Shut them down.
All right. Well, we got a lot of help on that one. As usual, we like to open up the floor to members and others that might have questions. So, Christine, you've got someone over there?
One word that you haven't mentioned in your talk is methane. And I've read a lot of studies that some people are more alarmed by the buildup of methane than they are of CO2. Could you talk on that?
Thank you for the question. Two-thirds of the greenhouse gas forcing is fossil fuel emissions and mainly carbon dioxide in the atmosphere. Methane is much more potent per molecule than CO2, maybe 30 times or on a 100-year time scale. You have to talk about the time frame. Over a 100-year time frame, the greenhouse warming potential of methane is about 30 times that of CO2. On a short time scale, like 10 or 20 years, it's 80 times more potent per molecule. So yes, but within 10 years, every methane molecule becomes a CO2 molecule. So if you take the long view, all of methane is a CO2 problem. And yes, there's a lot of methane in permafrost in the Arctic, on the land, and in shallow seas. The evidence is that methane is increasing again in the atmosphere. When I was in charge of the network in the early 1980s, methane was increasing rapidly, 1% per year, and then in the 90s it leveled off at like no increase, and now it's going up again. And we can look at the isotopes of methane and say, nope, that's not Arctic, that's not permafrost, it's low-latitude wetlands, tropical wetlands, rice cultivation, and wetlands in subtropical areas so far. Now, yes, there's a lot of methane in the Arctic, there's a lot of methane in permafrost. In the water column, most methane will be eaten by microbes before it gets to the surface. bubbles make it all the way up. So really shallow, big deposits of methane in the future could be a big source of methane. I'm not so worried about methane right now. And I think, yes, there's methane from frack gas, right? Leakage. You have to get the leakage down below 2 or 3% for methane to be better than coal, because it's so much more potent per molecule. So we really have to restrict fugitive methane emissions from fossil fuel construction. That's really important. Sanitary landfills, it's not cow farts anyway, it's cow burps. It's eructations out the front end, not the back end. And if you want to still eat your steak, then feed the cattle seaweed. If you feed the cattle seaweed, they don't burp methane. 60–80% reduction in their methane burps if you feed them seaweed. So we can deal with some of the methane from animals, flatulence, and from fracked gas. In terms of natural methane bombs in the Arctic, we better not let that happen. We better be careful.
You have talked about how most of this climate change is human-caused,
Yeah.
and it's the emission of fossil fuels.
Yes.
We had a speaker here several years ago from Canada who talked about how fossil fuels will find their own level, like water. As long as the demand is there, the supply will reach us. And I would like to know your comments about reducing demand, particularly as I look about this room, and we are largely retired people, older people with money, and many of us, our aspirations, our personal aspirations, are to travel a great deal.
Yes.
If we could give up some of our flying, would that not have a significant effect?
It would be very, very important. I'm as guilty as any of you who fly. My grandchildren, my children don't live near me. We have 4 grandchildren. We have to fly to Utah or Santa Monica to see them. And my wife says, we're going to see the kids, so we do it. And she also is in charge of our vacation travel. Yes, I like to go to Hawaii. I like to fly. What I do personally is I buy carbon offsets for that. I pay for that carbon. And there are many, you can go on websites and find this. Now, it's kind of like buying indulgences. Yes, you should reduce your flying as much as you can, but then if you're still flying, pay for that. The polluter pays. If you're the polluter, pay for it. And so if you fly for, it's about $1, about a penny a mile. If you fly 25,000 miles a year, then you can buy a carbon offset for your flying for about $250. Your driving is much less. If you drive 10,000 miles a year, you can offset your driving emissions for about $30. So until we have a price on carbon at the state and national levels, tax yourself. Put a carbon price on yourself. Sure, reduce your emissions as much as you can, but then if you still want to see your dying mother in Virginia or your grandchildren in another state, and you have to fly to get there, and I think the limit is something like 500 or 600 miles. Under 500 miles, drive in a efficient car. More than 500 or 600 miles, flying is better than driving. We don't have rapid 200-mile-per-hour trains like Europe or Japan or China do. I wish we did, because that would be a solution for our near-term transportation. What I did, I put solar panels on my house, 10-kilowatt system, and I charged my electric car, my Chevy Bolt I drove here in, with the panels on my roof. So I gather sunshine to charge my car. No emissions when I'm coming here. In the winter, not so much. In the summer, I get more than the power I need. I sell it back to Puget Sound Energy. But we can all do that. We can all be more efficient in our diet, not waste food. We can be more efficient with our light bulbs, et cetera, and we can support state and national efforts to put a price on carbon.
Thank you very much for mentioning that brave young 16-year-old Greta from Sweden. She's my hero. Again, the younger generation, of course, has more skin in the game because it's going to affect them more. Notwithstanding the new in-chief of the climate study proposed by the White House, who believes that CO2 is a good thing, if you take a look at the example in France, my friend there says that if you ask almost everybody on the street if they believe in climate change, they will say yes, and they go around recycling or doing all these good things. So Macron then puts a few pennies more tax on fuel, and you get gilets jaunes. And this is the reality. We all want to believe in it and do the right thing, but when it comes to our pocketbooks, then it goes out the window. Thank you.
I have a question. 10 years ago or so, there was the UN Ocean Report came out, and I remember they talked about the threat of what they called ocean collapse because of warming, acidification, and overharvesting. I'm curious if you could just elaborate on your understanding of what ocean collapse means and what the implication is for life on Earth.
Well, my short summary was that the oceans are getting hotter, more sour, and breathless. That warmer water holds less CO2, and ocean acidification is advancing extremely rapidly, and we see the effects already at high latitude. Ocean circulation can change. There's some evidence that the Gulf Stream is slowing, and this actually affects the rate of sea level rise on the east coast of the U.S. So ocean circulation is changing, a warmer stratified ocean. There's less mixing of nutrients into the sunlit zone, so global ocean productivity will probably decrease. Probably a third or more of all the ocean species are associated with coral reefs. They are the tropical forests of the ocean. If we lose the coral reefs, we lose that 30 or 40% of marine species. So ocean collapse is certainly in our future, and we're getting more tropical fish off our coast, right? Salmon are moving further north. They're catching salmon in the Arctic Ocean that they never caught before, and we're getting some tropical species coming in that we never saw before. I love salmon fishing. I love to eat salmon. If it had to be a choice of should I stop fishing for salmon in Puget Sound? I have. Should we let the orcas have enough salmon that they don't starve and go extinct? Yes, I would do that first. I would stop eating salmon. I would recommend restaurants stop serving king salmon, for example. So we can help with ocean to prevent the collapse of the ocean. But the first thing is stop the growth of atmospheric CO2 but in your own life and then in your political life.
I'm thinking about the 45% who do not believe in the science, as in one of your early slides, you said 55% of Americans do. When you or your colleagues involved in giving the same kind of lecture to groups give such a lecture in which the group primarily has a profile that falls in that 45%, what is the reaction that you receive?
Well, I've been giving climate talks for about 30 years, and most of them are to friendly audiences with people who are open-minded. I specifically was invited to confront a group that I knew would be hostile. This was on Mercer Island. They call themselves the ultra-conservatives. And the first hour was something that had appeared in the British television called The Great Global Warming Swindle. A bad propaganda piece, you may have heard of it. And then my job in the second hour was to refute that. And they shouted me down on every slide. They called me a communist. I didn't get through my talk at all. So that was the worst. That was the very worst. Mainly, and I need to talk more to more conservative groups. I need to reach out to them, business groups especially. I want to talk to real estate agents about sea level rise, for example, on Whidbey Island. So yes, I've talked to school groups, church groups. Unitarians are especially friendly. I helped form the climate action team at the University Unitarian Church, and now I'm active in the Whidbey Island Unitarian Church and their effort. Oh, I would say one thing that Unitarians are doing together with 7 or 8 other churches on Whidbey Island. It's called the Global Greening Collaborative. It's 7 or 8 different churches there. We are sponsoring an effort called Taming Bigfoot. So we're going to have a Bigfoot guy in costume riding up and down Island Transit and going to schools, and we're going to have a competition with teams so that people will have a month of data recording all of their greenhouse gas emissions from transportation, home energy use, and diet, and then collect data for 2 months. At the end of this, we have industry sponsors. We have prizes for the people who have reduced their emissions the most. This started 2 years ago in Jefferson County, in Port Townsend, with Bob Binshadler, a retired NASA glaciologist. And last year it was done in Edmonds and in Seattle. And we're launching this spring, Earth Day, on Whidbey Island. And so that's something that communities can do. What does it do? Maybe it's not to make you feel guilty, to say, what are my emissions? What is my personal carbon footprint? Maybe I'll reduce it, maybe I won't. I'm still going to fly some. Maybe I don't eat steak one day less a week or something like that. Maybe turn the light bulbs out or whatever. Anyway, it's a matter of self-awareness and public outreach. So this is something that communities can do, and it's something that a group of churches on Whidbey Island are doing. I want to at least put in a plug for Taming Bigfoot.
Patrick Moore was the founding director of Greenpeace before he was thrown out as a heretic. And he believes that we're going to have to go to nuclear power before we convert to hydrogen economy. What are your feelings on that? I think it looks like you've adopted his idea of planting more trees to sequester the CO2, but what about nuclear power as a step?
Right. I saw that this became a little stumbling point between the Green New Deal and some talking points, whether or not to include nuclear. Now, my view is that I would not shut down an existing safe nuclear plant. We need fossil fuel power. Eventually, it'll have to compete in the market. In the U.S., we're not building nuclear plants. Bill Gates is investing in next generation nuclear, Terra, and there are a couple research plans. I don't think that fusion's going to come along in time to help us. When Germany decided to shut down their nukes, what did they do? They went back to brown coal, and their emissions went up. What happened to Fukushima? Same in Japan. You go back to coal. So I would not shut down a nuclear plant that would have us go back to coal-fired electricity. That's much worse. On the other hand, I'm not sure I would use the market forces to build new nuclear plants when right now the cheapest source of new power is renewable. It's cheaper than running an existing coal-fired power plant is to build a new wind or solar and get it up and running. That's actually cheaper most places in the U.S., and it will be globally. And once that happens, the market will take over. We won't probably build new nuclear plants unless there's a new generation of nuclear plants which are faster, cheaper, and safer. So I'm not in favor of shutting down existing nuclear plants. I'm not in favor of investing a lot of money, government money, in nuclear research.
Hi. There was a great article in the Guardian newspaper about a year ago, and they basically said by 2050 we would have the climate of San Diego up here between Seattle and Vancouver. And we have a lot of forested parklands. We have Seaholm Hill, we have the Chuckanuts, we have Sudden Valley, the 100-acre woods. How prepared should Bellingham be for the type of wildland fires that they have in California if we're going to have that climate?
I think that when I look at the data for wildfires in Washington State, and Hillary France gave a talk about this not long ago, she said 40% of the fires are now west of the Cascade Crest. It's not just eastern Washington anymore. So yes, Hoh rainforest, very rare. There are probably places on Vancouver Island that never burned in the last 10,000 years. We have to be prepared for more fires in western Washington because it's going to be drier and hotter. Now, in terms of, I think, as Cliff Mass, not my favorite person, what Cliff Mass has said that climate change, well, it's really going to be worse in the latter half of this century and mainly in other places, and really nothing's happened here yet. I disagree with all three of those. But he's right that climate change impacts here in Western Washington are less than in other places in the U.S. That's certainly true. And so we will have to adapt. I think that what I read in that article was that the climate of Seattle will move to the climate of Portland. Portland's okay. And the climate of Portland will look like somewhere down in the Central Valley of California. And the climate of LA is somewhere way down in Mexico. So we have the moderating influence of the ocean here, which really helps us. In the middle of the country, these changes of 500-600 miles or more, much bigger changes in terms of what the climate will be in 2050. And again, that assumes some trajectory for emissions of CO2, and we can change that. You could say the bad news is climate change is happening and we're responsible. The good news is climate change is happening, we're responsible, and we can do something about it. The future is uncertain, and it's up to us to change the future.
One of the pieces of good news is that renewable energy is becoming more and more cost efficient and outcompeting fossil fuels. However, today, it still costs a fortune to put solar panels on your roof. So I'm wondering what your thoughts are on the future of community solar, especially as it relates to the multitude of people in most communities that can't afford individual panels. Thanks.
Thank you for the question. I'm not an expert on community solar. I think it's a great idea, and I think that the more that people can buy a slice of solar, and renters can't put solar panels on the roof of their rental condo, but we can all be part of this. I had solar panels in Shoreline. It was a 3-kilowatt system. That was 10 or 15 years ago, and now the cost of my 10-kilowatt system is cheaper than the 3-kilowatt system. So the price of solar is coming down. It's coming down really fast. And there may be ways to finance this. Utility scale solar, I know that the utilities are very interested in this. So home solar is just one possibility. Utility solar is another. And community solar is something that a lot of people can buy into. I think it's a great idea.
Why is the atmosphere warming when the stratosphere is cooling?
Okay, yeah, she told me she was going to ask me this question. That we were in line together for the meal. The simplest explanation is that the greenhouse gases are warming the lower atmosphere. That's where the concentration of greenhouse gases is. The role of clouds is kind of, and the future role of clouds is difficult. Most people think that cloud feedback is going to be an amplifier of warming, going to make it worse. Now, the reason the stratosphere is cooling is that there are not many clouds up there, and the greenhouse gases are up. They get up there in a year or two. The mixing time from the ground to the stratosphere for stable gases, like CO2, is only a year or two. So when you release freons on the ground, they're up in the stratosphere in a year or two. Now, if you have greenhouse gases up there, they're sending more heat to space, but they're not trapping heat. So it's an increased emissivity of greenhouse gases in the stratosphere that cools the stratosphere while heat is trapped in the lower atmosphere. Thank you.